In this video, I will introduce some of the basic concepts of experimental design in the medical sciences. Our experiments generally start with two variables. When conducting experiments, we're interested in knowing whether one variable causes another variable. For example, we might be interested to know whether meditating daily for 1 week reduces stress. There are two variables here, meditation and stress. In this example, we refer to stress as the dependent variable. If we think of our two variables as cause and effect, the dependent variable is the effect. We refer to meditation as the independent variable. Again, if we think of our two variables as cause and effect, the independent variable is the cause. One way to remember independent variable versus dependent variable is that our effect depends on the cause. In other words, the value of our dependent variable depends on the independent variable. In our example, we want to know whether stress level is dependent on meditation. So we have our question, does meditation cause reduced stress? And we have a hypothesis that yes, meditation does reduce stress. Next, we need to recruit a sample of people. Once we have our sample, we could measure their baseline stress level. We could then have them meditate daily for 1 week. Then we could reassess their stress level to see if it was reduced. So, say we find that yes, people had less stress after meditating. Was it the meditating that actually caused the reduced stress, or are there alternative explanations? Here are a couple of other potential causes of the reduced stress. Maybe our participant's stress went down just by chance and it had nothing to do with meditation. Maybe we measured stress at baseline on a different, more stressful day of the week than our follow-up assessment. Or maybe we measured stress at different times in the day and this resulted in the decrease. Finally, it's possible that our participants reported reduced stress because they knew that meditation is supposed to reduce stress. The point is, our conclusion that meditation reduced stress may not be accurate because there are other possible explanations. We call these other possible explanations sources of bias in medical research. Bias is the extent to which our study's conclusions may misrepresent the truth. In medical experiments, we implement controls in order to limit bias and rule out alternative explanations as best as possible. Say, for example, we start just as before by recruiting a sample of people. But this time, we're sure to measure baseline stress at exactly 11 a.m. on a Wednesday. Then, instead of everybody meditating, we ask some people to meditate and ask other people to not meditate. Now we have a control or comparison group. Then, when we measure stress again, we measure it at 11 a.m. on Wednesday the following week to rule out any effects of time of day or day of the week. We find that stress was reduced in our meditation group, but not at all in our control group. So now we can ask again, did meditating cause reduced stress? We might be more confident in our answer now that we have added some experimental controls, but you still might be able to think of alternative explanations. For example, in our new experiment with controls, we still did not rule out the placebo effect or the chance that people who meditated lowered their stress just because they believed meditation works. The fact of the matter is that there is no such thing as a perfect experiment that is completely free of bias. The best we can do is introduce controls that reduce potential bias as much as possible.